In this video, we shall refer to the alternating series test. This test can only be applied to alternating series. An alternating series is an infinite series of this form or this form, where Bn are terms which are positive for all n. The signs of the general term in the alternating series alternate between positive and negative. The alternating series test states that assume that Bn is a sequence which is a decreasing sequence with positive terms, such that the limit of Bn as n tends to infinity equals to 0. Then the alternating series of this form and this form will be a convergent series. Let's refer to the following example. We have the series. It is a form of an alternating series because it has the alternating sign -1 to the power n to each of the general term, and together the Bn equals to 1 over n, which is positive for all n. We can see that the sequence Bn is decreasing because Bn plus 1 is always less than Bn for all n, and the limits of Bn is equals to 0. Therefore, by alternating series test, this series converges. Please note the following remark. If we recall the term test, it states that if a series which is formed by terms Bn converges, then the limit of Bn as n tends to infinity equals to 0. But in case if we have a series which the limits of Bn as n tends to infinity equals to 0, then it does not necessarily imply that the series converges. We cannot conclude by the term test whether the series converges or diverges by simply referring to the fact that the limit of Bn as n tends to infinity equals to 0. This series may converge or may diverge. However, if we further have the information that Bn is a decreasing sequence with positive terms, and if we additionally multiply -1 to the power n or -1 to the power n plus 1 to each of the term Bn in that series, then we form a new series which is in the form of an alternating series. Then we are guaranteed that this new alternating series converges with the use of the alternating series test. Therefore, the alternating series test is useful for us to construct convergent series which are not absolutely convergent. That is, the alternating series test is useful for us to construct some series which are conditionally convergent. That is, it helps us to construct some series of the form either in this format or this format, and they are convergent, but after taking the absolute value to those terms, we get a new series, but this series diverges. We can see that for this series, if we throw away the -1 to the power n, then we will have another series which is the summation of 1 over n, where n starts from 1 to infinity. That is a p-series, and by the p-series test, the series diverges. However, if we multiply -1 to the power n to that p-series, then we get a new series which converges. Therefore, the effect that multiplying -1 to the power n to some series which originally diverge becomes a convergent series. Therefore, an alternating series test is useful for us to construct some convergent series which are not absolutely convergent. Let's refer to this series once again. We want to show that this series, which is formed by terms an equals to -1 to the power n divided by n, converges conditionally. Therefore, we want to show that this series itself converges. However, the series which is formed by taking the absolute value of -1 to the power n over n diverges. Now, let us denote an to be -1 to the power n over n and bn to be 1 over n, which is actually equals to the absolute value of an. We consider the series which is formed by absolute value of an, then it is equals to the series which is formed by bn, which is 1 over n. This is a p-series in this format and p equals to 1. Therefore, by the p-series test, this series diverges. Therefore, the series which is formed by the absolute value of an diverges. Now, we can see that bn is a decreasing sequence because bn plus 1 is always less than bn. Also, this is a sequence with positive terms because all the terms bn are positive. Besides, the limits of bn as n tends to infinity equals to 0. Therefore, by the alternating series test, the series which is formed by term an, that is this alternating series with terms -1 to the power n over n, converges. And now, since this alternating series converges, but the series which is formed by taking the absolute value of those terms is a new series which diverges. Therefore, according to this definition, we say that the alternating series converges conditionally. Please make a pause and try the following questions. We shall discuss the solutions afterwards. Part A. We want to determine whether this series is convergent or not. Please note that this series starts from n equals to 2 to infinity because when n equals to 1, the denominator is 0, which is not allowed. But we can rewrite this series as this one, then we get a series which starts from n equals to 1 to infinity, which is what we are more familiar of. And we notice that this is an alternating series. It is a series with the form where the general term is of the form -1 to the power n plus 1 times bn, where bn is equal to 1 over brackets n plus 1 times lateral log of n plus 1. Here we notice that bn is always positive and the sequence bn is decreasing because bn plus 1 is less than bn for all n. And let us consider the limits of bn as n tends to infinity. That is, the limits of 1 over n plus 1 times lateral log of n plus 1 as n tends to infinity. We can see that the numerator is a constant 1, but the denominator tends to infinity as n tends to infinity. Therefore, the limits of bn as n tends to infinity equals to 0. Now, since this bn is a decreasing sequence with positive terms and the limits of bn as n tends to infinity equals to 0, therefore, by the alternating series test, the series converges. Part B, we would like to determine whether this series is convergent. This is an alternating series because the general term in this series is of the form -1 to the power n times bn, where bn equals to 2n over 5n minus 1, and this bn is always positive. If we consider the limits of bn as n tends to infinity, this time it gives the value 2 over 5, which is not equal to 0. If we denote an to be the term here in this series, then if we consider only the even terms, then the -1 to the power n, which is an even number, becomes 1. So the limits of a to n as n tends to infinity is equal to 2 over 5. Whereas if we only consider the subsequence containing all terms of an, then as n tends to infinity, this sequence tends to -2/5. Since these two subsequences converge to different limits, therefore, the sequence which is formed by terms an does not converge, and that means the limits of an when n tends to infinity does not exist. Since the limits of an as n tends to infinity doesn't exist, therefore, by the term test, this series diverges. The following is a sketch of the reason why the alternating series test is valid for this particular form of alternating series. The sketch of reason for the other form of the alternating series is also similar, but I didn't present here. Please refer to it by yourself.